My name is Irmak Uyar and I'm studying Industrial Engineering in Bilkent University. In this video, I will be conducting an experiment for my Physics 101 project. In this experiment, I am aiming to investigate the relationship between the orbital radius and properties of uniform circular motion, particularly examining how changes in the orbital radius affects the velocity, acceleration, and the centripetal force of an object in orbit. By varying the orbital radius and measuring the corresponding changes in these parameters, the experiment aims to better understand the dynamics of uniform circular motion. This is the frictionless plane that I used in my experiment. This puck works with electricity and it will put dots on my paper and help me do my measurements. Firstly, I'm placing my pin on my paper and taping it so that it can't move. On the next stage, I will be tying one end of my string to the puck and the other end to my pin. Before starting, I'm trying my experiment setup. Here I'm using the short string. After making a few attempts to make the puck spin around the pin, I'm making sure that the table is on and the time interval is set to 50 milliseconds. I repeat the action I perform by pressing the electric pedal and the friction eliminating pedal simultaneously. As you can see, in my initial attempts, I use a shorter string to rotate the puck. However, in this version I am currently performing, I am using a longer string. Afterward, I remove the tape from the pin and then the pin itself so that I can easily flip the paper. I have obtained the desired pattern and now I can move on to the measurements. I begin by connecting the center of the circle with dots created by device, which will greatly simplify measuring the consecutive angles. I am measuring the angles here with the help of a protractor, and I repeat this process for both the large radius circle and the small radius circle. After completing this process, I will also measure the lengths of the lines I have drawn one by one, because under ideal conditions, they should be equal to each other, but due to some non-ideal factors, there may be slight differences in their lengths. When I'm done with the measurements, I transferred the measurement results to the tables I created in Excel. As you can see, I have created a row containing the averages of the measured values. While entering my data, I also used a function that converts the angles measured in degrees to radians. Now that we have observed the measurements for the circle with lower orbital radius, let's examine the data for the circle with greater orbital radius. You can see the operations I used to obtain the data in the function row above as well. Finally, I am comparing the data I obtained. Apparently, the linear velocity remains constant, unaffected by changes in the radius. As I mentioned earlier, due to some non-ideal conditions, they have a negligible difference that can be disregarded. On the other hand, we can see the centripetal acceleration and the tension of the string decrease as a result of the increase in the radius.